Have you ever wondered why the universe behaves the way it does? Well, there's a whole field of study devoted to answering that question: physics. It's the science of matter, energy, and the interaction between the two. It's like the foundation of a skyscraper, the bedrock upon which our understanding of the world is built. Without physics, the skyscraper of our comprehension would crumble, leaving us in a pile of confusion and uncertainty. Physics is everywhere. It's in the smallest particles, the quarks and leptons that make up the atoms of our bodies. It's in the largest galaxies, the spirals of stars and dust that spin in the vastness of space. It's in the way a ball arcs through the air, the way a rainbow forms after a rainstorm, the way a compass needle always points north. It's in the invisible forces that hold our world together: gravity, electromagnetism, and the strong and weak nuclear forces. It's in the energy that powers our homes, the light that illuminates our nights, and the heat that warms our winters. It's in the waves of sound that carry music to our ears, the waves of light that bring color to our eyes, and the waves of electricity that power our technology. Physics is the language of the universe, a language of numbers and equations that describes the way things are. It's the language that tells us why apples fall from trees, why the sky is blue, why the stars shine at night. It's the language that allows us to predict the future, to know where a comet will be a year from now, to know when the next solar eclipse will occur. Physics is the key that unlocks the mysteries of the universe. It's the lens that brings the cosmos into focus, the compass that guides us through the wilderness of the unknown. It's the map that charts the territory of reality, the blueprint that reveals the architecture of existence. Without physics, we wouldn't have a clue about the fundamental principles that govern our universe. Did you ever stop to think about how much of our modern technology relies on physics? Let's start with electricity. It's everywhere, right? It's powering the device you're using to watch this video. It's keeping your food cool in the fridge. It's lighting up your room. But electricity isn't magic. It's physics. From Benjamin Franklin's kite experiment to Nikola Tesla's work on alternating current, physics has been instrumental in harnessing this powerful force. Moving on to semiconductors, which are the building blocks of all modern electronics. These tiny components control the flow of electricity in our devices. They're the reason your smartphone is smart, the reason your computer can process complex tasks, and the reason we can store vast amounts of information on tiny chips. It was the principles of quantum physics that led to the discovery and development of semiconductors. And let's not forget about telecommunications. Have you ever wondered how a video call works? How you can see and hear someone thousands of miles away in real time? Well, it's all thanks to physics. The principles of electromagnetism allow us to send and receive information over vast distances at the speed of light. These are just a few examples of how physics underpins our technology. From the cars we drive, to the planes we fly in, to the medical equipment that saves lives, physics is at the heart of it all. It's not just about understanding the universe, it's about using that understanding to improve our quality of life. Physics has given us the tools to create incredible technology, to connect with each other in ways we never thought possible, and to solve problems that once seemed insurmountable. It's made our lives easier, safer, and more connected. So next time you flip a switch, remember the physics behind it. It's not just a simple action, it's a testament to centuries of scientific discovery and technological innovation. It's a reminder of how far we've come, and a hint of where we might go next. But physics isn't just about high-tech gadgets and cosmic phenomena, it's in our everyday lives too. Let's start with the weather. Ever wondered why the sky is blue? It's all down to physics. The Earth's atmosphere scatters sunlight in every direction, but blue light is scattered more because it travels in smaller, shorter waves. This scattering, known as Rayleigh scattering, is a fundamental principle in physics, and when it comes to rainbows, it's physics at play again. Rainbows are formed when sunlight is refracted or bent by droplets of water in the atmosphere. Each color in the rainbow represents a different wavelength of light, bent at a different angle. A beautiful display of physics in action. Next, let's talk about sound. The music you listen to, the words you hear, they're all waves of pressure speeding through the air. These sound waves vibrate your eardrums, and your brain interprets these vibrations as sound. Understanding the physics of sound can even help musicians fine-tune their instruments. Motion is another everyday example of physics. From the moment you get out of bed, you're a living demonstration of Newton's laws of motion. When you walk, your foot pushes against the floor, and due to Newton's third law, the floor pushes back, allowing you to move forward. And let's not forget light, the reason we can see the world around us. Light is both a particle and a wave, a concept that comes from quantum physics. When light hits an object, it either gets absorbed, reflected, or transmitted, depending on the object's material. This interaction between light and matter allows us to see and perceive colors. So you see, understanding the basic principles of physics can provide us with a unique perspective on the world around us. It helps us grasp why the sky is blue, why rainbows have multiple colors, how we hear sounds, how we move, and how we see. Whether we realize it or not, physics is an integral part of our daily lives. What do you think is the connection between physics and other sciences like chemistry and biology? You might be surprised to learn that the link is much stronger than you think. Physics provides the foundation for all other sciences, serving as the bedrock upon which our understanding of the universe is built. Let's delve into the world of chemistry for a moment. The fundamental principles of physics are used to understand molecular interactions, the basis of all chemical reactions. For example, the laws of thermodynamics, which are rooted in physics, govern the energy exchanges that happen during chemical reactions. Without physics, we wouldn't be able to understand why certain reactions occur or predict the outcomes of these reactions. Moreover, quantum mechanics, another branch of physics, explains the behavior of particles at the atomic and subatomic level. This understanding is crucial in chemistry, as it explains why atoms bond to form molecules and how the properties of these molecules dictate their behavior. So, in essence, without physics, the world of chemistry would be a mystery. Now let's turn our attention to biology. At first glance, it might seem that physics and biology are quite distinct. However, physics plays a crucial role in understanding the physical processes that happen within organisms. For instance, the principles of fluid dynamics help us understand blood circulation in our bodies. Similarly, the laws of thermodynamics explain how organisms maintain their internal temperatures. Even the functioning of our eyes, which enables us to see the world around us, relies on the principles of optics, a branch of physics. So, whether it's the study of molecules in chemistry or the exploration of life processes in biology, physics is there, providing the fundamental principles and tools to explore and understand these fields. It's like the universal language that all sciences speak, allowing them to communicate and connect with each other. From the smallest cell to the largest ecosystem, physics is the common thread that ties all sciences together. It's a testament to the profound and far-reaching influence of physics in shaping our understanding of the universe. Where is physics taking us? What does the future hold? Imagine a world where computers operate at speeds currently unimaginable, where clean, limitless energy is harnessed from the fusion of atoms, and where space travel is as common as an international flight. These are not mere fantasies, but potential realities that could be unlocked through advancements in physics. Quantum computing, for instance, is a burgeoning field that could redefine our understanding of information processing. Traditional computers use bits, which exist in either a 1 or 0 state, to process information. Quantum computers, on the other hand, use quantum bits or qubits, which can exist in both states simultaneously thanks to a property of quantum mechanics known as superposition. This could exponentially increase computing power, enabling us to solve complex problems that today's most powerful supercomputers can't handle. Then there's fusion energy, a concept that's been dubbed the holy grail of clean energy. Fusion is the process that powers the sun, where hydrogen atoms collide to form helium, releasing vast amounts of energy. If we can replicate this process on Earth, we could potentially have a near-limitless clean energy source. The challenge, of course, lies in the physics. Creating and controlling a fusion reaction is no easy feat, but the rewards, they're astronomical. Speaking of astronomical, let's talk about space travel. With our current understanding of physics, it takes about 9 months to travel to Mars. But what if we could shorten that journey? Physics might hold the key. Concepts like warp drive and wormholes, while currently in the realm of science fiction, are grounded in real physics. They suggest that space-time can be manipulated, potentially allowing us to traverse vast distances in a blink of an eye. These are just glimpses of the future that physics might unlock. As we delve deeper into the fundamental laws of the universe, who knows what other groundbreaking discoveries and innovations await us? The future of physics is not only exciting, it has the potential to revolutionize our world. So why does physics matter? It's the backbone of our understanding of the universe, the driving force behind technological progress, and an indispensable part of our daily lives. It links together other scientific disciplines and paves the way for future advancements. Physics isn't just a subject, it's a lens through which we decipher the world around us. Physics doesn't just help us understand the world, it helps us change it. So next time you see a rainbow or use your smartphone, take a moment to appreciate the physics behind it.